Hey everybody. Today we're talking about end behavior of functions, limits at infinity, horizontal asymptotes. So a lot of times we're not interested in what a function does at a particular value, but rather um, the long-term behavior of the function. What happens to it eventually? Does it settle down to a particular value? Does it just increase without bound? Or maybe does it oscillate forever? For instance, consider the concentration of a drug in the bloodstream, time t hours after injection. You might get a graph that looks something like what I have here. Eventually, the concentration of the drug in the bloodstream will settle down towards zero, though it may never get exactly to zero. It can just get less and less, sort of asymptotically. Let's try and make this observation a bit more mathematical, a bit more precise. You might recognize some of the language I'm using here as limit talk. Eventually, it gets smaller and smaller. These sorts of words are limit words. If a function f of x gets closer to a particular value L as x gets larger and larger without bound, we say limit as x goes to infinity f of x equals L. For instance, in that concentration of the drug in the bloodstream example, we have the limit as t goes to infinity f of t equals 0. As time gets greater and greater, the concentration of the drug in the bloodstream starts to approach zero eventually. We can also talk about limits at negative infinity. So here I've drawn the arctangent function, and we can see that from the graph that as x goes to negative infinity, as we move further and further to the left, the y value gets closer and closer to negative pi over 2. While we're at it, we can observe that the limit as x goes to infinity of this function is pi over 2 as we go further and further to the right. You might notice those horizontal lines that I've drawn, that I've made them dashed. So the notation there is exactly like it was for vertical asymptotes, and the language is parallel as well. We call these horizontal asymptotes. When you have a limit as x going to infinity f of x equals L, or limit as x goes to negative infinity f of x equals L, we say the function has a horizontal asymptote. Notice that the horizontal asymptotes have the form y equals L, so these are horizontal lines, in contrast to the vertical asymptotes, which look something like x equals c, so vertical lines. Hopefully it's clear already that a function can have up to 2 horizontal asymptotes, but no more than that. One word of warning. A lot of times we see these situations where when x goes to infinity or negative infinity, the function also goes to positive infinity or negative infinity. So here this function y equals 1/10 x cubed, we have the limit as x goes to infinity is infinity. It just grows without bound. The y value grows without bound as x grows without bound. In such a situation, we say that the limit does not exist. The function has no horizontal asymptote.